Hello everyone, I'm Said. In this video, we are going to talk about blocking collection in C# and how we can use it to implement a Kafka-like message broker. Blocking collection is a thread-safe collection that can be used for producer and consumer pattern. That our purpose is implementing a way to consume and produce messages that are detached from each other using blocking collection. We are trying to achieve what Kafka does in their APIs. Here we have one interface that tries to implement to achieve that purpose. We have three methods for consume, produce, and also close. That is kind of Kafka APIs. I already created another video about how to use Kafka in .NET. So if you're curious how to use Kafka in .NET, you can go and watch that video as well. So let's go and create implementation. I already added the class without any implementation. We are going to go one by one, produce, consume, and close. Also, we have one API that already I added the interface for producing a message on a specific topic. Here we have the singleton, because this message broker gonna save all the state, all the messages that we are pushing and producing to the topic. So we need to register it as a singleton to keep all the track of the messages. And also we're gonna have another background job for consuming those messages, right? Currently it is nothing, just a background service. And then later on we implement the execute async method. Okay. So let's go for implementing the produce one. We know that we're gonna have multiple topics and then each topic contains a list of messages. So we need to have one kind of dictionary to save this topic and related messages. I'm going to add one concurrent dictionary here. So you know that this concurrent dictionary, another collection gonna be thread safe. So we have one string as a key for the topic name, and also we have a blocking collection, which is the type of string. We are going to call it topics here. Blocking collection, we can use it for this kind of purposes when we want to just add an item to the collection and somewhere else in your application you are going to consume or get that message. For the same purpose, we can use also .NET channels as well. But to be honest, I find channels a little more complicated than blocking collection. It is really straightforward, and then you can just see it as a normal collection in our .NET application. We're gonna have one dictionary here for saving the topic and then the messages, right? Let's put one logger as well, just to track them. Okay, logger, let's put the read-only as well. We're gonna get it from the DI here. So now someone in API gonna call produce to sending one message to our message broker. Okay. We are using the void because there is nothing special. It is all in sync operation. So nothing deal with the task. First of all, we need to check if our topic collections that contains the incoming topic or no. If there is no entry in the dictionary for this topic, we are just going to instantiate a new blocking collection for this one. We need to care order of the messages that we are sending to this collection, because as you know, in Kafka we have kind of offset for each message that is very important for keep tracking of your messages. By default, blocking collection is doing that for us, but we can also change this default behavior. Actually, the default behavior is using a concurrent queue behind the scenes is like that. Default behavior is using a queue as an underlying data store. So each time that you are sending a message, it will put it in a queue. We know that queue is FIFO order. So first message will be first out, first in, first out. But also if there is a scenario that you are saying that we always caring about the last message that is coming to this collection. We can use the concurrent stack as well here. A stack is LIFO, last in, first out, right? So depends on your scenario, but here we're gonna keep the default behavior as a queue. Now we know that if the topic doesn't exist, we already created a blocking collection for that topic. And now produce is about adding a new item to the collection. Simply we can say topic.try add. We can just put the message here. Because we are using the generic one, as we know in Kafka, is saving everything as a binary, but the API is in the NuGet package getting a string from us. So here we need to use JSON serializer and then just serialize incoming message object. We already add the incoming message to the blocking collection. There is lots of another APIs and other methods that we can use, like try add, try take, or even we can use multiple blocking collection together if we have, or keep tracking of multiple collection based on your logic. You can, for example, say take from one of them, take from any, right? Like this. It's really cool collection, to be honest, and I really like it. So we implemented produce method here, and let's put a log here as well, just to see it is working properly. I'm just saying that got a message to produce. That's enough. And let's put a breakpoint here as well. And now I have API for producing message. The topic is test topic, just a constant value. Let's run the API and let's see if it's working or not. Okay, this is also working. So let me, this produce message. It's coming here for the first time. We don't have the topic in concurrent dictionary, so we add it. And also, okay, got a message to produce. Let's do it again. Okay, so we are trying to send and produce the messages. So if we see this one here, we have a test topic and then contains two messages, our serialized model for the message. Okay, so let's continue. This is the part for implementing the producer part. How about the consuming? The consuming part is a little bit tricky, but let's do it. Let's do it together. We have background service here because, as we know, there should be a consumer always listening to the message broker. And as soon as a message coming to the queue, we're gonna get it and then process it and do whatever we want based on our logic. Here we have the message broker as our singleton object here. We need to start listening on it. It's gonna be a little tricky here. Let's do it first and then after you will know. So usually in the background service, we are trying to say, as long as this cancellation token is not canceled, this while loop gonna work for us. A message broker dot consume constant dot topic. It should be the same topic as we are producing. We are trying to say there is a timeout for that one. Let's say 5 seconds. Here we are going to say our message is based on the model because we need to deserialize that string to our model as well. We didn't implement the actual method here. What is the purpose here? The purpose is take one message from the blocking collection, if there is any, and then deserialize that string to our model and then send it back to the caller. Okay. We need to check, depends on your business logic. Here we are trying to say if it doesn't contain the topic, then we can throw exception here, because always the order should be like, first we need to create a consumer and then consuming on it. But here I am going to again instantiate a blocking collection as well, because this is a background service in my case, and then always background service is gonna run before even consuming or producing any message to the blocking collection. Simply we can say var message topic dot the topic one. Here we have try take. That is a blocking operation here. This try take will wait until there is a new message coming to the collection or there is a timeout. So we're gonna say that if there is a message, please put it in this message. Okay, because this is a try one, we can use this if block here. If it's true, then we are going to deserialize. Here also we're gonna pass the timeout as well, because it depends on your scenario. You can put a timeout or wait forever until there is a new message. But for me, I always try to put a timeout on that one. Also, when I was using the Kafka as well, it is better. I don't know why, but when you're blocking some threads forever, it is, I think, not a good idea. Let's just try it again. Wait for 10 seconds, 30 seconds. If there is no message, then try again, then try again. Here we return JSON serializer, deserialize the message to the T from the message that we already got. If there is nothing found, then we return default as a null, because after 10 seconds, we didn't get any new message, then we just return null. This is just exactly like Kafka is doing, because Kafka also implement the pooling mechanism. I think RabbitMQ is like pushing to the consumer, but the Kafka is like pooling. The client part sending a request, waiting for a while, like a timeout here. If there is something in the topic, then we'll get it and then send it to the client one. So here also we are doing the same. We are blocking here on the try take method. If there is something, then we return it to the caller. The color is here. Okay, let's put it 10 seconds. We know that the message can be null or not null. We say if the message is not null, then it means there is a message in the queue. Let's put a logger here as well. Got a message to consume with ID and name. And then message ID and then message.name. Perfect. We don't want to process anything here, just log it. Else, if it was null, we can say there is no message for the given topic. But there is a problem here. The problem with this code. What is the problem? We have background service and hosted service. The background service is an implementation of the hosted service. But the point for the background service is it will not blocking the API, your startup, and then it will just running in a background way. But there is a catch here. What is the catch here actually? Let's run the code and then we can see by this way our Kestrel should not run. Let's just run the code and let's see. This is our console. You can see there is no log like app start listening on a specific port or the other logs. And then here we are seeing our log. There is no message for the given topic, which is coming from our background service. Right here and here, but there is no Kestrel. The problem here is, you can see there is one warning here that we are using or returning a task, but here we didn't do anything like the asynchronous. So even if we say task.completed task, like await, still the problem is there. What is the problem? Actually, I made a video a while ago about this issue, that most of developers think that because we have an async task here and also there is a await operation doing something here, this while loop will be run in a background. But this is not true, because the await and async is running in a sync way until we have a task and then detaching this current thread from the running. What I mean here, the solution actually, you can watch that video to going through very detailed scenario, but the solution here is we need to use the task.yield here, because just this one is a really good reason for using in this scenario, because here our operation are all in sync. It means it is waiting for running all this operation in sync without detaching this thread to run all of the other code, like, I don't know, like Kestrel or other even hosted services, the other stuff. But by adding this task.yield, you already saying that you can go back to the thread pool and waiting there, and I am doing my stuff in the while loop. That is the trick. That video was really nice, and when I was creating it, it was really surprising why this async await is doing like that. And to be honest, it's making sense because you are doing something in sync. There is no task returning from your method. Okay, so let's run the code again, and now we can see here web Kestrel is running, and then there is our log here. Now our consumer is actively listening on that blocking collection. So now if I just push a message, where am I? Okay, I got the message. So let's do it here again. You can see I am getting the message here. Once I produce a message, let's wait for a while that, okay, there is no message for a given topic. And then if I just run it, you can say how fast it is for just immediately taking the message from the blocking collection and then consume it, process it in an async way. You are detaching the producer part from the consumer part, right? So here, as long as I am producing a message, the consumer part will try to get a message immediately from the blocking message. The things that we are actually doing for message broker like Rabbit or like the Kafka part, there is only one thing remain, that is closing part. First of all, if you check Kafka APIs, there is kind of subscribe, unsubscribe, because Kafka is saving a state when you are trying to subscribe. It is kind of stateful, and then after that you can use the consume method. But here, because I just try to simplify that, I didn't implement that subscribe. The close part for Kafka, you have to using the close method when you are trying to, in case of, for example, application shutdown, right? At the end, you have to call the close to actually clean up all the resources that you already taken from application, network part, anything. Here, what we want to do is, if the topic is not exist in the dictionary part, here we need to throw exception. There is no way, because when we want to call the close, we should have topic, we should have the consume part. So there should be an entry in the dictionary for this topic. So we need to just throwing exception here, saying like, I don't know, there is no topic. If it is exists in the dictionary, so we are going to say this topic, and then the blocking collection, there is a method for complete adding. That is a really good one, because we are saying that there is no more message coming to this blocking collection. So if someone else from the other part of the application trying to add another item to that blocking collection, it will throw exception, because kind of we say that this is completed, right? What we can do here also, I forgot to add, in the consume part, also we need to say this blocking collection as far as is not completed. Because if it's completed, then we should not listening or trying to read from it. There is two methods, is adding completed or is completed. We need to use the is completed because is adding completed is just saying that there is no more message coming, but maybe there is more message in your collection already that you didn't consume. So we need to use the is complete, that making sure there is no message coming, and also we consume all of those messages in the collection. And for saving the memory, we need to just remove this topic from the dictionary. Simple, just like that. And then when we need to call this close method, it is here. Because as I said, the background service is implementing the hosted service, so we can access to the stop and start. Here we need the stop async. Simply we can say close for this topic, constant.topic, and then that's it. Nice. I think this is the very simple way of implementing a message broker in your application. I know that there is lots of different ways, different library out there you can use, like, I don't know, mass transient, because it has the version of the in-memory as well, just like here. But it is always good. It is always enjoyable that you can implement your own stuff with all the options you already have in the .NET, right? So all I want to say that you can create your message broker using blocking collection. Simple, just like that. We already implement that. That's it. Thank you for your time. Don't forget to subscribe to my channel. Lots of interesting video coming. Thank you for your time again. Until the next video.